Hello, math people. Today we're moving on in our 3D geometry unit. Yesterday, if you remember, we did the basics. We went over some vocab so that as we progress through this unit, you've got the terminology down to understand what we're talking about. Hopefully that went well for you. Today, we are moving on to surface area. So we're going to be doing surface area for a few days, but for today's lesson in particular, we're going to be working on the surface area of prisms. Hopefully you remember what a prism is. A prism is a 3D figure that has two identical bases that are parallel from one another, and we're going to be finding the surface area of them. So the first question that you might be asking yourself, which we will go over, is what is surface area? So very simply, surface area is the sum. So what we'd be adding, it's the sum of the area. I'll put the areas of all the faces in a prism. So a prism, depending on the type of prism, has a certain number of faces, and the surface area is the area of the surfaces, the area of the faces. Sorry about that. And there's a couple ways that you can approach this. This requires a little bit of patience if you're not a visual person. So for me, the first time I learned this, I remember I had trouble with it because I had a hard time unfolding the shapes and seeing what they looked like flattened out. But hopefully I can break this down for you today. So imagine we have a prism. Here on the screen you should now see a rectangular prism. It's got a width, it's got a length, and it's got a height. And I'm going to call the base the top or the bottom if we could see it better, but that's what we're going to call the base. Now, if you want to find the surface area, you need to be able to visualize all of the surfaces of this prism. So this prism, being a rectangular prism, has 6 faces. And what we're going to do is imagine that we are unfolding this prism. So as you can see here, it's kind of starting to be unfolded until we have it all laid out flat. This, the two-dimensional representation of a three-dimensional figure, is known as the figure's net. So right now, I'm circling this, we're looking at the net of a rectangular prism. And we can see there's the top and the bottom. That was over here. It's all color-coded. The two sides, and then the back and the front of the figure. Now that you can see everything laid out flat, you could probably pretty easily find the area of each of the 6 surfaces and then sum them all together. So the best thing we can do is put pen to paper and try to do one of these with actual numbers. So here we have a rectangular prism, and it's got some measures. It's 4 inches by 7 inches by 3 inches. And I mean, if you want, pause the video and try to draw out the net yourself. See if you can get what the net should look like and label it. That's the most important thing, with the proper measurements. And then you can unpause and see if you have the same thing as me. But here we have the net. Your net might be drawn in a different position, but it should have a top and a bottom, and the top and the bottom should both be 7 inches by 4 inches, and then the two sides, which are blue, should be 4 inches by, this measure here is 3 inches. You can see that from over here. If this is 3, then this is 3. And then the front and the back, the two green figures, should be a 7 by 3 rectangle. So altogether, the surface area is going to be the top and the bottom. So this is how I typically label my work. I'll do top and bottom, so I know exactly what I'm talking about. And the top and the bottom are 7 inches by 4 inches. So 7 by 4. Now, what I have in parentheses is the area of 1. That's the top or the bottom. But since there's 2, a top and a bottom, we have to double that. So it's going to be 28 doubled. And then we'll call it the sides plural. There's 2 of them. The sides are these blue 4, it's supposed to be a 4, by 3, and there's 2 of them, so we have to double that as well. So it's 12 times 2. We're doubling that. And then we also have the front and the back, which in this image are green. I'm going to call that F/B, front/back. And the front and the back, as you can pretty clearly see, are 7 by 3. And there's 2 of them, so we're going to double that. So it's 21 times 2. And then, pretty simple, you're going to add everything together. So 28 times 2 is 56. And then we've got 12 times 2, it's 24. And then we've got 21 times 2, which is 42. And we're going to sum all of that because that's how you find surface area. It's the sum of all the surfaces, and that's going to sum up to 122. And since we're talking about a 2-dimensional measure, this is a 3D figure, but surface area is just the area of a bunch of 2-dimensional figures. The label for this is going to be inches squared. You'd be tempted, I think, to say, oh, it's going to be inches cubed because we're talking about 3 dimensions. But no, surface area is the surfaces which are flat surfaces. And flat surfaces are 2-dimensional, so this is going to be inches squared. So yeah, here's one more rectangular prism in case you want to see one more. We've got this nice purple rectangular prism. It's 6 by 9 by 5. If you're having trouble drawing the net, here is an alternative. You could kind of label these with words like this that I'm drawing in black. I'm going to call this the front. Now there's a front to this and an identical back. So front/back. Now what are the front and the back? Let's draw it really quick. They are 9 inches, it's right here, by 5 inches. And there's 2 of them. Now we also have these 2 side rectangles. I'm going to try my best to draw those in black. And those are 6 inches by 5 inches. So I'm going to call those side. Those are the 2 sides. And just rough sketch, it's 6 inches by 5 inches. And there's 2 of those. And then lastly, we've got what we could probably call the top and the bottom. And the top, you can see pretty clearly. All right, the top is 9 inches by 6 inches. So top/bottom. And there's 2 of these rectangles. And they are 9 inches by 6 inches. So now instead of drawing the net, you've drawn all the pieces, but just kind of detached them. It's the same concept, and for me personally, it's a little bit easier to do this. Maybe you'll find it's easier for you as well. And now we can put this all together for the surface area. So this surface is a rectangle. It's 9 by 5, and there's 2 of them. So that's 90. For this, it's 6 by 5. And double it because there's 2 of them. So that would be 60. And then the last surface is this 9 by 6. And there's 2 of them because it's the top and the bottom. 9 times 6 is 54, times 2 is 108. And then we could sum all of this together. So that would be 258, if I'm not mistaken, and meters squared, because we're talking about a 2-dimensional measure. It's a flat surface. But yeah, that's the surface area of a prism, and in particular a rectangular prism. However, we're also going to be looking at triangular prisms today. So really quickly, I'm going to go through the same exact thing I did, but I'm going to do it with triangles. So imagine a triangular prism. Look at that magic. And the base of a triangular prism is a triangle. That's why it's called a triangular prism. Prisms are named after their bases. If we could unfold this bloop, bloop. There would be the net. So we'd have the top and the bottom, or excuse me, not the top and the bottom, the front and the back, aka the green triangular bases, the bottom, which we can't see in the original picture, but there is a bottom to it. It's a rectangle. And then we've got a blue side, which you can kind of see the hint of blue there, and then the yellow side. So that's what a triangular prism would look like. Two triangles and three rectangles. And these are a little bit trickier because you've got to try to label them. So let's look at one with actual numbers. Again, if you want, pause the video, see if you can yourself come up with a net or at least a sketch of all 5 pieces of the triangular prism. And if you did that, it would look something like this. You'd have 2 triangles, and the triangles would have measures of 12 by 5, and then the slanted side, that's this side right here, would be 13 inches. The yellow frontish side here, that would be 5 inches by 8 inches. Those dimensions are pretty clear to see. The bottom, which we can't see here, but when you unfold it, we know there's a bottom, would be 12 by 8. 12 by 8. My mouse is kind of tracing over that. And then the blue, which is, this kind of looks like it's like a wedge or something. The blue is like the slanted side of it. It's 13 by 8. And I know it's 8 because if this bottom here is 8, this side is parallel to it, so that has to be 8. So the blue is 13 by 8. Anyways, now you can pretty easily put together the surface area for this. It would be we'll call this the front and the back. These are the 2 green triangles. A triangle is base times height divided by 2. So the base is 12, the height is 5 divided by 2, but you have to double that because there's a front and a back. So 12 times 5 is 60, divided by 2 is 30, but times 2 gets you back to 60. So the 2 green triangles have an area of 60 square centimeters. Then we've got, I'm going to do the yellow side. So the yellow side is, I'll call this side 1. Side 1 is a rectangle that's 8 by 5. There's only one of those, so you don't have to double that. 8 by 5 is 40. Side 2 is, let's call that the blue over here. That's 13 by 8. And then the other thing would be the bottom, the red bottom. That would be 12 by 8. So all together, we could add all of these surfaces up. We've got 104, and we've got 96, and then we have got to add all 5 sides together for the total surface area, and that would be a total of 300 square centimeters. Ooh. We'll do one more. One more where I'm going to, instead of drawing the net, I'm going to draw all the individual pieces. So I've got the bases, which we'll call the front and the back. And the front and the back are triangles, right triangles. And they are 3 by 4. So their area is going to be 3 times 4 divided by 2. But double that because there's a front and a back. So 3 times 4 is 12, divided by 2 is 6, times 2 is 12. Then you've got, I'll trace it, the back rectangle. So I'll call that the back. The back is 3, and then this bottom is 4, because if this front is 4, parallel to it is the back, which is 4. So we've got a rectangle that's 3 by 4, and that's easy. That surface is 12. Next, we'll do the, let's do the bottom. The bottom is easy. It's a 4 by 4 rectangle. Bot for bottom. So it's a 4 by 4 square, rectangle, whatever. 4 by 4 is 16. And lastly, we've got the wedge-ish rectangle on the slant here, and that's 5 by 4. So we'll call that the side, whatever. You can call it whatever you want. So that's 5 by 4, 5 by 4, which is 20, and then you just sum everything. So 1, 2, 3, 4, 60, right? I think so. Anyways, 60 square yards would be the surface area of this prism. So yeah, today and the next few days we'll be doing surface area of various figures. Here's your intro lesson to it. Hope this helps. If you get stuck in any of the problems, feel free to send me a message or hop on the Google Meet happening later today. Have fun. It's supposed to be super sunny and nice out, so go for a bike ride or go look at the clouds by yourself. Don't be around people. All right, goodbye.